over NW practice exam, year 2017, question 19, part B. So in part A, we have decided the cathode and anode. We have separate the half cell reaction for each part. I just did part C, by the way, because it's part C4 calculates the standard potential. I was doing this in a way where I'm trying to determine who will stay in reduction. So it's just, by the way, we just flip the, whoever lost will go to oxidation. So we're now going parts, we have done part A and C. We just write the shorthand notation. There's a little special for this case. The example I showed in the class, usually they will have a solid involved. So whichever that solid is can be our electrode. But here, as we're writing in the question, the electrode actually, so if I'm just quickly gonna draw them, one of the electrode is platinum. Okay, that's our voltage. Okay, one of them is our platinum, which this is one of the useful material. The reaction really happens on that one. When we write shorthand notation, you don't need this number anymore. So part C is also done. So just let people know, okay? Since platinum is also part, let me be exactly the same on this. Okay, platinum is also part of the electrode. We won't need to involve this in the case. Okay, the next thing will be when I have my overreaction, and make sure I'm on the same page with you. Okay. So in the previous example, which is the same one as I did in the class, when we have a solid, we'll say, what does the solid turn into? Now we don't have this one. We'll still follow the same logic. What I will start with what was the species before, and end with what this species finally turned into. Are we cool with this? It's the only special part is this has to happen on a plate, a different metal that is being involved. Are we cool with this? So whatever the surface that we're going to play on, we'll put a dash on it. Okay. CR. All right. There is actually hydrogen plus in, but I'll just stop. The only thing I want to emphasize is this one. Okay, people are going to ask why you put all of them in it, because all of those, okay, all of those, they are aqueous, 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 all of those is in here. If you, there's another way to visualize this. Didn't we say platinum? There's a very, very long line. If I write this one very long, that will be this one. Make sense now? Okay, so whatever metal electrode you're using, everything else you can put a name. Cool? Okay, we'll do the same thing for the other side. So we also have a bunch of aqueous. Okay, this is also platinum. So a bunch of aqueous will be here. Whatever, okay, here. And our final palladium will be the last. Okay, we have manganese. Okay, is that off? Oh, yeah, of course, hydrogen plus. Okay. Oh, you don't have to have the last one, you know that. Okay. There's a cool part that I like on this. Okay. How do I know where to put this one? So if you visualize this, it's pretty much just this two line getting very high. Make sense now? Okay. So where is the other? Okay, this line is this one. So we're putting whatever electrode, aqueous, okay, this one, and electrode. So it will be clear for whoever reading this, they can get all the material for this cell. Cool? Okay, a follow-up question. In the reality, is this one in the separate cell or is actually in the same one? In the same, yes. When you really do electrochemistry, we don't have two separate. It's in the same class.